Hello everyone, welcome back to the Power Quality lecture series. So in the coming videos we are going to discuss about power quality monitoring. What are the different monitoring considerations? Power line disturbance analyzer, power quality measurement equipments, harmonic spectrum analyzer, flicker meter, disturbance analyzer, etc. What is power quality monitoring? So, power quality monitoring is the process of gathering, analyzing, and interpreting raw measurement data into useful information. And the process of gathering data is usually carried out by continuous measurement of voltage and current over an extended period. The process of analysis and the interpretation has been traditionally performed manually, but in the recent years, the advancements in signal processing and artificial intelligence fields have made it possible to design and implement intelligent systems to automatically analyze and interpret these kind of data into useful information with minimum human intervention. So, power quality monitoring programs often driven by the demand of improving system-wide power quality performance. So many industrial and commercial customers have those kind of equipment that is sensitive to power quality disturbances, and hence it is more important to understand the quality of power being provided. So you know the examples of these kind of facilities are like networking and telecommunication facilities, semiconductor and electronic manufacturing facilities, and biotechnology and other pharmaceutical laboratories, financial data processing centers, etc. So these kind of equipments are really important to monitor the power quality issues, because it will be greatly adversely affected by the power quality issues. And before coming to the power quality monitoring, we should have some objective to power quality monitoring of power quality issues. One should clearly define the monitoring objective before embarking on any power quality monitoring effort. The monitoring objectives often determine the choice of monitoring equipment, triggering the threshold, methods for data acquisition and storage, and analysis and interpretation requirements. There are many common objectives of power quality monitoring. A few are listed in this video. First one is the monitoring to characterize the system performance. So this is the most general requirement. A power producer may find this objective important if it has the need to understand its system performance and then match that particular system performance with the need of the customers. So we should ensure your system performance is meet your consumers power quality requirements. So this kind of approach is a proactive approach to power quality monitoring. So by understanding the normal power quality performance of a system, a provider can quickly identify problems and can offer information to its customers to help them match their sensitive equipment's characteristics with the realistic power quality characteristics. Then second objective is monitoring to characterize the specific problems. So many power quality service departments or plant managers solve problems by performing short-term monitoring at specific customer site or different loads. So this is a reactive mode of power quality monitoring, but it frequently identifies the cause of equipment incompatibility, which is the first step to a solution to the any particular power quality issue. The third one is monitoring as a part of an enhanced power quality service. This is another objective. So many power producers are currently considering additional services to offer customers. So one of these services would be to offer differentiated levels of power quality to match the need of specific customers. A provider and a customer can together achieve this goal by modifying the power system or by installing the equipment within the customer's premises in order to increase the power quality of the power. Then next one is the monitoring as a part of a predictive or just-in-time maintenance. So power quality data gathered over a time can be analyzed to provide information relating to the specific equipment performance. So in this equipment maintenance can be quickly ordered to avoid the catastrophic failure, thus preventing the major power quality disturbance, which ultimately will impact overall power quality performance. So this one maintenance is one of the objective to reduce the power quality issues. Then fifth one, you can another kind of power quality monitoring consideration is power quality monitoring as a part of facility site survey. The site surveys are performed to evaluate the concerns for power quality and equipment performance throughout the facility. This kind of survey will include the inspection of wiring and grounding concerns, equipment connections, and the voltage and current characteristics throughout the facility. This kind of site survey information is gathered. The following information can be normally we can gathered. These are first one is the nature of the problem. By using the site survey, you can check the nature of the problem, like what is the nature of the problem, like data loss or nuisance trip, component failure, control system malfunctions, etc. Then characteristics of sensitive equipment which experiencing the problems. Then the times at which a problem occurs. Then coincident problem or non-operations, like some of the things like capacitor switching already which is scheduled one. So this kind of a non-operation, how it affect the power quality problems. Possible source of power quality variations within the facility. Whenever a motor starting or capacitor switching, power electronic equipment operation, arcing equipment, these kind of things, how these are the main sources of power quality variation. So we should monitor this also. Then existing power conditioning equipment being used. Any kind of power quality conditioning equipments like STATCOM or DVR is using, we need to check the data related to that. Then electrical system data like online diagram, transformer size, impedances, load information, etc. So this is the what are the things that included when you are conducting a site survey, that is as a part of monitoring, power quality monitoring. Another important consideration for power quality monitoring is that we should determining the what to monitor. Power quality encompasses a wide variety of conditions on the power system, and important disturbance can range from very high frequency impulses caused by a lightning stroke or current chopping during a circuit interruption to a long time over voltage caused by a regular tap switching problem. So this variation of power quality problem is very high. So we should determine what to monitor. So the range of conditions that must be characterized creates the challenges both in terms of monitoring equipment performance specifications and in the data collection requirements. So it is very important to identify or determine what to monitor first. Then next consideration is choosing monitoring locations. Choosing the monitoring locations. Obviously, we would like to monitor conditions at virtually all locations throughout the system to completely understand the overall power quality. But however, such monitoring may be prohibitively expensive, and there are challenges in data management, analysis, and interpretation. It's very difficult to monitor in all locations. So, fortunately, taking measurements from all possible locations is usually not necessary, since measurement taken from several strategic locations can be used to determine the characteristics of overall system. So, thus it is very important that monitoring locations be selected carefully based on the monitoring objectives. So, this is another consideration before going to the power quality monitoring. Then next one is disturbance monitor connections. That is the recommended practice is to provide input power to the monitor from a circuit other than the circuit to be monitored. So some manufacturers include input filters and or surge suppressors on their power supplies that can alter the disturbance data if the monitor is powered from a same circuit that is being monitored. That is some manufacturers, some equipments already equipped with some kind of filters or surge suppressors inbuilt in that equipment that will automatically reduce the power quality issues. For example, the grounding of a power disturbance monitor is an important consideration. So the disturbance monitor will have a ground connection for the signal to be monitored and the ground connection for the power supply of the instrument. Both these grounds will be connected to the instrument chassis. For the safety reason, both of these ground terminals should be connected to the earth ground. However, this has the potential of creating ground loops if different circuits are involved. So, the recommended practice is to provide input power to the monitor from a circuit other than circuit to be monitored. The next one is setting monitor threshold. So disturbance monitors are designed to detect conditions that are abnormal. So therefore, it is necessary to define the range of conditions that can be considered normal or abnormal. Some disturbance monitors have pre-selected threshold that can be used as a starting point. That is, we need to set a monitor threshold. The best approach for selecting threshold is actually to match them with the specifications of equipment that is affected. So, otherwise is to set the threshold fairly tight for a period of time and then use this data collected to select appropriate threshold for longer duration monitoring. So before going to monitoring the power quality issues, we should analyze this kind of or collect the lot of disturbance data and then set the from the selected data we need to select or choose a threshold the above which that will cause an abnormal operation of the equipment. So setting a monitoring threshold is another kind of objective or consideration when we are planning for power quality monitoring. And then quantities and duration to measure. So sometimes when characterizing system disturbance, it is insufficient. It is sufficient to monitor only the voltage signal. Before going to the detailed analysis, we cannot predict which are the quantities that is to be measured and which is the duration of measurement. In some cases, in order to characterize the system disturbance, voltage signals, monitoring the voltage signals itself is sufficient. For instance, the voltage provides the information about the quality of power being delivered to the facility and characterize the transient and voltage sag that may affect the customer equipment. However, there is a tremendous amount of information in the current associated with these disturbances that can help determine the cause and whether or not equipment was impacted. By measuring the voltage, you will get some information, but there are more information you can gather when you are monitoring the current waveform. You can determine the cause of the power quality issues and whether it will be impacted on the equipments, how much depth it is impacted. Like that, you can analyze if you are measuring the current waveforms. Also, the current measurements are required if harmonics are concerned, since the current characterize the harmonic injection from the customers onto the power system. So current measurements, so we need to, before going to the monitoring the power quality issues, it's better to identify which are the quantities and duration to measure or monitor, whether we need to go for current monitoring or voltage quantity, current quantity, etc. And this kind of current measurements are used to characterize the generation of harmonics by nonlinear loads on the system. So by measuring the voltage is not sufficient in order to characterize the harmonic impact of caused by nonlinear load. So that is what is the one consideration before going for a power quality monitoring. And the duration of the monitoring depends upon the monitoring objectives. So for example, if the objective is to solve the problems that are caused by voltage sag during the remote fault on the utility system, monitoring may be required for a significant length of time because the system faults are probably rare. And if the problem involves capacitor switching, it may be possible to characterize the condition over the period of a couple days, 1 or 2 days. So depending upon the problem, we should we should determine the duration of the monitoring. The harmonic distortion problems and the flicker problem should be characterized over a period of at least 1 week to get a picture of how the load changes and how the system variation may affect these levels. So this monitoring duration also very important. Quantity which is to be monitored and the duration of the monitoring. These two things are very important for power quality monitoring. Then the finding the source of a disturbance. So the first step involving in the identifying the source of a disturbance is to correlate the disturbance waveform with the possible causes. Once a category of causes has been determined, example load switching, capacitor switching, fault, etc., the identification becomes more straightforward. So the source of a disturbance is very important. Then you can go for the monitoring, power quality monitoring. So there are many guidelines to help to find out the source of a disturbance. One of the example is suppose a power interruption close to monitoring location will cause a very abrupt change in the voltage. So power interruptions remote from the monitoring location will result in decaying the voltage due to the stored energy in rotating equipments and capacitors. So there such kind of guidelines are available before you are going to determine the source of a disturbance. So these are the power quality monitoring considerations. So what is very important to identify the different objective of the power quality monitoring and what are the things we need to consider before going to monitor the power quality issues.